if you have these very large tables, these very large matrices, then, you still have to store the value 0. But my understanding is that there's a way that you don't have to store the value 0, and that's where a lot of your efficiencies come in. Can you explain that a little bit?
You can think about the Boolean matrix or the Boolean sparse matrix, where every entry has basically two values, true or false. And you can think about true representing that, yes, there is a connection, and false saying, no, there's no connection. But with sparse, this Boolean type becomes a binary operation or a binary value. Do you want the entry to hold the value true? This is first one. The second one is entry ij has a false value in it, or the third option is there's no data in that entry, so it's missing. And the way that sparse matrices take advantage of that in terms of memory consumption is via the actual implementation of the data structure. And so there are different formats to represent sparse matrices. The most common ones, I would say, are CSS and CRS. It's compressed sparse row and compressed sparse column. Basically, with CSR and CSE, the matrix is represented by a hierarchy of 3 arrays. Usually you would have an array representing the row indices, and then the second one in the hierarchy is the column indices, and lastly, you would have the values. With CSR, the first array would contain every entry for every row, whether on some values in a specific row or not. Then for each row, you would have a pointer to the next array in the hierarchy. That would be the columns. And then you would have one entry for every value. The same thing goes for the actual values array. And so you're just containing information for existing entries. Non-existing entries are not present, so there is no memory being used to represent those. It goes even further. In case the matrix is hypersparse, there are additional ways to compact this even further. If the matrix has only just a single value, for example, if you're dealing with a Boolean matrix where all of the entries in the matrix are true, then there is this optimization in GraphPlus called ISO value, which means that this value array, which usually is of size number of active entries in the matrix, becomes just a single value. So what's the value at entry ij? If the entry is present, you look up the ISO value. Oh, it's true. And everybody is sharing the same true value up until the point where you're mixing or entering a false, and then it's no longer ISO, and then you would pay the price for keeping track of which entry is true or which entry is false.